Lesson 3.6, Proportional and Non-Proportional Relationships. Our essential question today is, how do you write an equation in function notation to represent a graph? Our vocab word, function notation, slope-intercept form, might look pretty familiar to you because in the last section we used the exact same equation for our arithmetic sequences. So remember that our arithmetic sequences we said would represent a linear relationship. So the graph is a line. Now we're working with, instead of looking at a sequence, looking at the graph and writing the equation. So we're trying to fit together everything. The sequence, the graph, the equation, and the linear nonlinear function piece. So our equation is f of x equals mx plus b. M, which represented the common difference in our arithmetic sequences, is now represented by the slope of the line because those things are the same. They're the same. The rate of change, the slope, the common difference, that it goes up or down each time, those are all the same thing. The letter B in the formula, or in the equation, represents the y-intercept. So that is where the line crosses through the y-axis. Or, remember how we said intercept is very similar to intersect? You can think of it as where the line intersects with the y-axis. Okay, so to write an equation for this line in function notation, I'm going to start with my function notation. And I'm going to remind you that the m is going to be the slope of our line, and that the b is going to be our y-intercept. So those are the two pieces of information that we need to get from the graph. So I'm going to clone my graph over here. Remember that when we find the slope, we always start at the left, start at the point on the left. So here's my point on the left. Now, slope is rise over run, or the change in y over the change in x. You rise up or down, and you run to the right. You always run to the right, because you're starting at the point on the left. So, am I going to need to rise up or down to get to the point on the right? I'm going to have to go down. Down 1 to be exact. So my rise is -1 because I went down 1. And then my run to the right, I need to go over 4. So my slope is -1 over 4, or -1/4. My intercept point, where my line goes through the y-axis, remember this is your y-axis right here. This is the origin right here. So my y-intercept is right here, down 1 from the origin, so it is -1. Now I just need the rest of my equation, f of x equals, and then the letter x after the slope. Make sure that you have a sign in front of your intercept. So a sign meaning if it's a positive intercept, a plus, a negative intercept, a minus. So that it's not a number written right next to the variable, like the slope is. So that's our equation. Next one. Same process. Find the slope first. Start at the point on the left. Remember, rise over run. So I'm going to go up or down and then over to the right. So start at the point on the left. I'm going to have to rise 1, 2, 3, 4. And then run 1, 2, 3, 4, 5, 6. So if I rise 4 and run 6, that slope is not written in lowest terms. So I'm going to reduce it to 2/3. 2/3. And that should make sense to you if you look at my line, it could have been rise 2, run 3, rise 2, run 3. And that would have given us the exact same line. Remember that when the points are not drawn in on the graph, you can use any points that you want. On this one, because there were 2 drawn in for me, I just used those 2. Okay, now the intercept. Where my line crosses the y-axis, here is my y-axis. The point that it intersects, the blue line intersects with the y-axis, was right here. It was that new point that I just put on, so it was at positive 1. So positive 1, fill in my f of x equals, and my letter x, and I'm done. The third example, you may notice, does not have points drawn in on the graph for us. So I am going to need to do that. Start with my formula again. So for my slope, rise over run, I need 2 points to use. The first one that I'm going to look for is my y-intercept, because if we're writing an equation for the line, by looking at a graph, hopefully you can see from the graph what the intercept is. So I'm going to use that point. Now I'm going to trace along the line to the right of that, and the next point that looks good, that crosses at the corners, is right here. So, starting at the point on the left, I'm going to have to rise 3, run 2, so my slope is 3 halves. My intercept point is down here. This is where my line crosses with that y-axis. So if this is 0, my intercept is negative 2. Fill in my x, f of x equals, and there's the equation. Next one. This one has something that's a little bit different from the last one. So this slope, my intercept is right here at the origin. Then tracing over to the right, the next point that looks good is right here. So my slope, I'm going to have to go down 1 and over 3 to the right, so negative 1/3. And my intercept on this problem, where my line crosses with that y-axis, is 0. 0. So my equation looks like this. And you don't even have to write the plus 0 on the end. So it's more common to see just f of x equals negative 1/3 x. So when the intercept is 0, there is not a number after x. There is not a number after x. Now, I think I'm going to change this. I don't think that we need to see another graph like this. And I'm going to go with okay, I am going to go with a graph that looks like this, a horizontal line. And we're going to talk about how to write an equation for this line. When you have a horizontal line, I hope you remember that we said the slope of all horizontal lines is 0. It's 0. So if I plug in a slope that's 0, what is this equation going to look like? So f of x equals, my slope is 0 because it's horizontal. It has no slope. Now what is my intercept? Where does my line cross with the y-axis? At 3. So right here, it's up 3 on the y-axis, so 0x plus 3. 0 times anything. 0 times anything, we remember, is 0. So that means that this doesn't even have to be written in our equation. So the equation for this horizontal line is just f of x equals 3. F of x equals 3. Every point on that line has a y coordinate of 3. no matter what x is. So no matter what you plug in for x, you're going to get 3. So when the intercept is 0, you do still see the x in your equation. You do still see the x. But when the slope is 0, you see only the intercept. Okay, you're ready to write your summary? And your homework is a worksheet with a versatile on each side where you have to match equations to their graphs.